Okay? Now, last thing I want to say about these planets, let's talk about the rings. Do these planets have rings? Yes, you can see it right here. However, do you see rings in this picture or this picture? Do you see rings in any of these pictures I've been showing you right here on these planets? No, we don't. We don't see rings. That doesn't mean they aren't there. It just means they're hard to see. What other planet had hard to see rings? What other planet had rings, but it was very difficult for us to see it? Jupiter. Jupiter, that's correct. Let's see if we can figure this out, though. Why were the rings of Jupiter hard to see? They didn't have ice, right? So Jupiter's rings were made out of only rocky material because it was too warm where Jupiter was for ice to form in the rings, right? So is that the reason that these rings are hard to see? Would it make sense that it's too warm for ice around Uranus and Neptune? Do we expect these to be only rock? No, it's even colder. So the rings of Uranus and Neptune should be made out of ice, but they're hard to see. That seems like a contradiction, because ice should be reflective, and it should be easy to see sunlight bouncing off of it. What it means is, the rings of Uranus and Neptune are made of a different kind of ice. They're so far away from the sun that it's cold enough, remember, for methane to turn into ice. So the rings of Uranus and Neptune are made of methane ice. But that's not the whole explanation for this, because it seems like I just got done saying that we can see these clouds here because they're reflecting sunlight. So I seem like I'm contradicting myself a lot right here, but I'm not, because it turns out that something else is happening to that ice. Something a little bit complicated, but I'm going to explain it right now. Check this out. The ice in the rings of all the planets is being exposed to the sun basically all the time. And what the sun slowly does is it destroys the material of that ice very slowly. And if you've got water ice, like Saturn's rings are mostly made out of, what's water? What's water made out of? If we were to break water, what two substances would we have if we broke the water? If we broke the actual molecules of the water? That's right. Hydrogen and oxygen. Water is H2O, meaning it's made of 2 hydrogen atoms and 1 oxygen atom. So if you let sunlight break down H2O, it forms 2 gases. And those gases are just lost to space. And so what you have is just a piece of ice that slowly shrinks over time, okay? But it's going to look the same all that time, because anything that's broken just leaves. But methane is not H2O, okay? Methane, instead of being made of hydrogen and oxygen, is made out of carbon and oxygen. So when the sunlight starts to break down this methane ice, it breaks into carbon and oxygen. The oxygen is a gas, so it flies away, but carbon is typically a solid in these conditions. So the carbon is left behind on the surface of the ice if you leave it in the sunlight for long enough. And does anybody know what color carbon is? What color is carbon most of the time? Somebody's asking if methane is CH4. That is correct. carbon, hydrogen 4. What color is carbon most of the time? It's black. Carbon is black, right? And if you're having a hard time picturing it, if you're writing with a pencil, that thing we call pencil lead, that's not made out of lead anymore. It hasn't been made out of lead for decades because kids were eating it, eating pencil lead, and that's not good for your brain. So we decided to make pencil lead out of carbon. So that stuff in your pencil and the stuff that coal is made out of, that's what carbon typically looks like most of the time. So if you have a piece of of methane ice and you leave it in the sun for, thousands of years, the sun will slowly break down the surface of that ice and leave carbon on it, which makes it so that the ice can't reflect sunlight anymore and turns black. So the correct way to say this is that the rings of Uranus and Neptune are made of carbonized methane ice. Okay? Carbonized methane ice. So it would be reflective. We would be able to see the rings of Uranus and Neptune if we went out and cleaned the ice. But the ice is dirty because the sun is breaking it down and leaving carbon on the surface. That doesn't happen to these clouds because these clouds are circulating into the atmosphere. They get out of the sunlight before that carbon can break down. Does that make sense? So, but the rings are stuck in the sun all the time. So that's happened to them. All right, last thing I want to say, and then I'm going to let you guys go. One thing, this last bit is Neptune only. When we've been looking at the rings of Neptune, and let me show you an actual picture here. These are enhanced pictures using infrared, so you can see these rings a little bit better. The rings of Neptune have, we discovered them only about 40 years ago. And during that entire time, they've been disappearing. And they've been disappearing so fast that maybe they will be gone in about 100 years. Neptune is losing its rings. It seems to be losing its rings. And we do not know why that is happening. It doesn't seem to be happening to the other planets, but it is happening to Neptune. That said, it is possible that this might be a seasonal effect. For example, maybe they're just partially melting away right now, and maybe they could come back in another season. I'm not saying that that is the answer here, but would it make sense if Neptune's been losing its rings for 40 years? Could that be a seasonal thing? Does that make sense? Seems like it doesn't make sense, right? If it's been losing those rings for 40 years, it really doesn't seem like it could be a seasonal effect. But, yes, somebody pointed out, though, you're thinking about Earth years. The years of Neptune. Neptune's further out from the sun, so what does that do to its years? How long are the years of Neptune? What's going to happen to those years? Yeah. Because the orbit of Neptune is larger and because it feels less gravity from the sun, it moves much slower, and those years are going to be very long. And how long is a year on Neptune? 165 years. A year on Neptune is 165 Earth years. So if we divided that into 4 for 4 seasons, if you divide roughly 160 by 4, you get 40 years. Because 40 times 4 is about 160, which is just a little bit less than a Neptune year. So the seasons on Neptune would be about 40 years long. So we've only been watching the rings of Neptune for one Neptune season's length of time. So if this is a seasonal effect, we've got to watch for another 120 years to figure that out. Does that make sense? Actually, even, fun fact, we actually haven't known about Neptune for 165 years. So what does that mean? We have never seen Neptune ever do yet. What have we have never seen Neptune do yet? Yep, we've never seen Neptune complete a full orbit. We can tell it's going to because it's tracing out that ellipse. We know it's going to complete an orbit, but we have never actually seen it fully happen. So that's kind of cool to me. Anyway, that's all I have to say about these planets. Uranus and Neptune both have a whole ton of moons, but I'm not going to be talking about them today.